Hello, in this video we will look at how to calculate the mean, also known as the expected value, of a discrete random variable, as well as the standard deviation for a discrete random variable, or a probability distribution based on a discrete random variable. With the Casio fx-CG50, we need to make sure that we're in the statistics mode in order to do most of these calculations. So we'll press number 2. Now we have a list of values here. This is from a different example. So we're going to hit the F6 button to go to delete all, and we'll just confirm with F1. Go over to the other list, delete all, confirm with F1. All right, so the mean of a discrete random variable is also known as the expected value of a discrete random variable, or expected value of x. It is a way of predicting a future value of a random variable, or a future value of an experiment. There is no way of knowing the exact outcome that we will have. There is no way of knowing what the average or expected number of times would be for one single experiment. This is what we would calculate or compute if we were to do this experiment repeatedly for many times. So I'm going to show how to do this with the Casio calculator. If you'd like to see this with a more detailed explanation, there's another video as well. Example 4.5 says, find the expected value of the number of times a newborn baby's crying wakes its mother after midnight. Let the discrete variable represent the probability that a newborn baby's crying wakes its mother after midnight in a given week. So x represents the variable. In this case, we could have 0 through 7. We're just going to enter all of these into the first list. 5, 6, 7. And then their associated probabilities will go into the second list. In this case, we can just type them in as a regular old division problem. So 10 divided by 50. 21 divided by 50. 9 divided by 50. And 4 is 3 divided by 50. I'm just making sure I didn't skip one here. And then 2 divided by 50. And then 2 divided by 50 again. And lastly, 7 is 1 divided by 50. All right, so now we've got them all entered into our lists. Now we want to calculate the mean, and in this case, we can also calculate the standard deviation. So we're going to use the F6 key until we get back to the main menu here. We'll go to Calculate, F2. Now I just want to confirm that my settings are set correctly. So we're going to press F6. We're going to make sure that our x variable, in this case x, is our first list, and our frequency is list 2, which we have set perfect. We can press Exit once, and then calculate a 1 var statistic. This is only one variable because all we're worried about is how many times a newborn baby's mother a newborn baby's mother is woken up by the newborn baby. So it's only one variable. So we're going to click F1 for one variable, and we'll get that the mean of this probability distribution, mu, is 2.4, and the standard deviation is 1.45 or 1.5. Note that we are going to use the population variable for both of these because we're trying to take into account every single possible future prediction. When we do these calculations, again, it's a theoretical probability. We'll never actually be able to get these values in the real world, but notice also that there is no sample standard deviation. So we're only going to be dealing with the population standard deviation. So the expected value is the expected number of times per week a newborn baby's crying wakes its mother after midnight. In this case, we would expect 2.4 times per week. And we would have a standard deviation of 1.5 for this. All right, now we'll go on to another example. This one says a hospital researcher is interested in the number of times the average post-op patient will ring the nurse during a 12-hour shift. For a random sample of 50 patients, the following information was obtained. What is the expected value? So we're going to go through here and do the same thing. We're going to try and calculate the population mean, mu, for this discrete probability distribution. Our x values are 0 through 5. So we're going to need to type these into our calculator. In this case, we'll hit Exit, and then we can use our cursors to navigate, we can just delete 6 and 7 from our previous example. Now I want to delete this entire list because all my probabilities are completely different. So I can get back to the main menu by pressing exit, use the F6 key once to get to delete, and we'll delete the entire list. And we'll just enter this in now. So 4 divided by 50, 8, I'm missing it, 8 divided by 50, 16 divided by 50, 14 divided by 50, 6 divided by 50, and the last one is 2 divided by 50. One thing to keep in mind with probability distributions is that the probabilities must all add up to 1. The sum of p should be 1. So we can just double check that real quick. 4 plus 8 is 12, plus 16 is 28, plus 14 is 42, plus 6 is 48, plus 2 is 50. So 50 over 50, perfect. Going back to the calculator, we now want to go to F6 twice so we can bring up the calculate screen. Again, we should confirm that our settings are correct. We have our X value for list 1 and our frequency for list 2. We're good there. Press exit once. And again, we're only talking about the one variable. In this case, it is the number of times the average post-op patient will ring the nurse in a 12-hour period. So we're only dealing with one variable. So we're going to click 1var, and we will get that the population mean is 2.32. Again, this is the expected value. We would expect a patient to ring the call bell 2.32 times. And this is, again, the average after many, many, many patients are observed. All right, we have one more example. In this case, we are working on a gambling or betting example. Suppose you play a game with a biased coin. You play each game by tossing the coin once. A biased coin means that it is unfair. One side is going to land up more often than another. And here we go. The probability of landing on heads is 2/3. Therefore, it's biased towards landing on heads. So if you toss a head, you pay $6. So tossing a head means that we lose $6. If you toss a tail, you win $10. All right, so we've got a winning and a losing. So we've got two different outcomes. One's a win, one's a loss. If you play this game many, many times, will you come out ahead? Well, first thing we need to do is define the random variable x. Well, the random variable, the experiment is tossing a coin once. If we toss a coin once, we've only got two outcomes, either heads or tails. But this is a discrete random variable or discrete probability distribution, so we need to figure out what the numbers would be for these coin tosses. Well, in this case, we can deal with the amount of money either won or lost as our random variable. So in this case, if we win the bet, we win $10. But if we lose the bet, we pay $6. So we're going to make this negative $6. Next, it's going to ask us to fill out the probability distribution. We have it halfway filled out. We have the x variables. Again, the x variables is the money from this example. So from here, we just need to figure out what this means. So the probability of landing on heads is 2/3. And if you land on heads, you lose $6. So the probability of losing is 2/3, and the probability of winning is 1/3. So the last thing we need to do is calculate the expected value or the population mean. So what we can do here is grab our calculator again. We can press exit twice, bring us back to the home page. I'm going to press F6 to delete the entire list. We'll go over to list 1, hit delete the entire list. Now we can just type these in. $10 is the winning, negative $6 is the losing. Make sure we use the negative sign, not the subtraction button. otherwise we'll get an error. The probability of winning is 1/3, so 1 divided by 3. The probability of losing is 2/3, so 2 divided by 3. And now we have our values here. I'm going to press F6 twice. Now we've done this for the first two examples. The setting is not going to change. Once we press calc, we don't need to worry about checking the settings for every single time. But again, we want to make sure that we're using the x variable as list 1 and the probability or the frequency as list 2. Since we're only talking about money here, money is the only variable, so the population mean or the expected value would be negative 67 cents. So we would expect to lose 67 cents per hand or per game. Now, there is no way of losing 67 cents in a game. If I toss the coin once, I can only get either heads or tails. If I land on heads, I lose $6. If I land on tails, I win $10. There is no way of getting 67 cents per game. However, if I played this game repeatedly and averaged up the winnings and losses over a long period of time, my average would eventually become 67 cents negative. Now, with this type of a probability distribution, where we only have two outcomes, it's probably easier to just make this probability distribution have a third column, x times p of x, where we just multiply these two values together. 10 times 1/3 is 10/3, and 6 times 2/3, negative 6 times 2/3 is negative 12/3. If we were to add these two together, the sum of x times p of x would be negative 2/3, which is where we're getting this 67 cents loss per game. And that's how we can do the find the mean or expected value and the standard deviation for a discrete random variable using the Casio fx-CG50.